All right, number 61, determine whether the sequence is arithmetic. If so, what is the common difference? So we just did a similar one, number 60 in the previous video. Um, we are looking to see if our numbers are increasing or decreasing by a constant amount. Because I can see these numbers are getting bigger, a common difference would be positive. If those numbers were getting smaller, a common difference would be negative. All right, so to get from 28 to 33, we are increasing by 5. To get from 33 to 38, we are increasing by 5. And to get from 38 to 43, oh, we are increasing by 5. So you need to check through your entire sequence to see if you're increasing by that amount every time. When that happens, then you have an arithmetic sequence. So yes, it's arithmetic. And then what is the common difference? That is that amount we were increasing or decreasing by. So that's our D. That's going to be, nope, not a 6, a positive 5. Okay, so number 62, find the 118th term of this sequence, 7, 10, 13, 16. So I can see that that is arithmetic. We are increasing by 3. And then we have a little hint. Write an explicit formula and then use that to find the 118th term. We're not going to sit here and write out 118 numbers until we get there. We will make a mistake and lose track and get the wrong answer. I promise you. So let's just know how to write an arithmetic sequence. We'll do that using an explicit formula so we can jump to the 118th term. So explicit formulas, an equals a1 plus n minus 1 times your common difference. Really, all we need to know are the first term and the difference, and then we can simplify our formula and then put it to use. So our first term is 7. So 7 plus n minus 1. Our common difference we said was a positive 3. And now to simplify this, we're just going to distribute that 3. 7 plus 3 times n is 3n. 3 times a negative 1 is a minus 3. Then we have some like terms. We have a 7 minus a 3. So we'll just combine those. 7 minus 3 is 4 plus 3n. So there's our arithmetic sequence. To find the 118th term, we're going to do a sub 118. All we have to do is plug in a 118 for the n. So 4 plus 3 times 118. And when we do that, and we're just simplifying over here. This is, just kind of think of this as a label. When we replace the n with a number, we're finding the 118th term. So we put a 118 in for n. 4 plus 3 times 118, we would multiply first, then add 4. And that gets us to 358. And then if we look at our options, oh, we get excited because that was option D, 358. All right, number 63. Find the 119th term of the sequence. So same thing, we're going to write an explicit formula for this arithmetic sequence, and then we will use that formula to find the 119th term. So you can see up above, we have our explicit formula, an equals a1 plus n minus 1 times d. So let's find our first term and our common difference. So our first term is 4. 4 plus n minus 1 times our common difference. What are we increasing by or decreasing by? In this case, it's increasing, so it will be positive. To get from 4 to 11, we would add 7. To get from 11 to 18, we would add 7. To get from 18 to 25, we would add 7. So our common difference is a positive 7. Now to simplify this, we will do some distributing. We're going to carry down the 4. This is a 7 times n, so positive 7n, and then 7 times negative 1 is minus 7. Then we will combine like terms. We have a 4 minus a 7. So our formula, a sub n, sub stands for subscript, equals 4 minus 7 is negative 3. I think on the last one I wrote you can see right here, I put the n term second. Oftentimes I will write the n term first, so the 7n, and then 4 minus 7 is negative 3. It really does not matter, your preference. But to find the 119th term, we'll do a sub 119. That says, okay, use your formula and plug in a 119 for n. We're going to do 7 times the 119 and then subtract 3. When we do that, we get 830. So that means that the 119th term is 830. All right, number 64. Viola makes gift baskets for Valentine's Day. She has 6 baskets left over from last year, and she plans to make 12 more each day. If there are 17 work days until the day she begins to sell the baskets, how many baskets will she have to sell? So if we think about the situation in words, here's what's happening. They're asking how many total baskets can she sell? That's going to be equal to, well, she's got some leftover baskets. So we're going to take her leftover baskets. Let's add on to that. Now she's going to be making baskets every day. So it says that she can make 12 baskets each day. And, well, actually, we're going to get to that. Hold on. Let's keep working with our words. We are going to take the number of days that she has to make baskets and multiply that by the number of baskets she can make each day. So made per day. All right, so let's fill in some information. Our total baskets, that's what we don't know. We'll just call that X equals the leftover baskets. So how many baskets does she have left over from last year that she can still sell? She has 6 of those, 6 baskets left over from last year. So 6 plus, and then she's got how many days? 17 work days times how many baskets she can make for each of those days. She's making 12 baskets a day. So when we simplify this, we have 6 plus, we will do that multiplication first. 17 times 12 is 204. And that gets us to 210 total baskets. And we look at our options, and there it is, 210 baskets. All right, number 65 is our follow-up, same type of question. Viola makes gift baskets for Valentine's Day. She has 20 baskets left over from last year. She plans to make 8 more each day. If there are 13 work days until the day she begins to sell the baskets, how many baskets will she have to sell? So we already wrote this out in words in our previous problem, so I'm just going to follow this structure again. So total baskets, X, that's what we don't know, equals her leftover baskets. In this case, she has 20 left over from last year, so 20 plus her number of days she has to make baskets times the number of baskets she can make a day. So there are 13 work days, so 13 times, and how many baskets can she make a day? Oh, she can make 8 baskets a day. All right, so 20 plus, let's do the multiplication first. 13 times 8 is 104, and then 20 plus 104 is 124. So she can make 124 total baskets. All right, number 66. Describe the association shown in the scatter plot. So scatter plot is just data plotted on a graph. And what we notice is that the points kind of seem to follow along a pattern going like this. As our temperatures increase, our sales are increasing. If I were to sketch kind of a trend of what's happening, that might be a trend line right there. Um, and all of those points are relatively close to that line I drew. So I would say that there's definitely an association here. And because that looks like an uphill line that would have a positive slope, this is what a positive association would look like.